So, big welcome to students today to this very fascinating class. Big welcome from Daniel and Sam to this class on mathematics and critical thinking. And one of the ironies of this class is that we use mathematics all the time. We get up at a certain time in the morning and look at our clocks that are giving us mathematical information about time. We consume maybe a coffee that has a certain mathematical quantity of milk and other ingredients. So there's maths happening all around us, even if we're unaware of it. So today we're going to look at the importance of mathematics and its application in the classroom. We're going to look at how if you write an essay, mathematics can be useful for adding a sense of reliability there. We'll look at Christian faith and mathematics. And many Christian philosophers have said what interests them about mathematics is this sense that there is an order in the universe that points to the God of order behind it. And then Daniel and myself were talking briefly before about how different denominational groups could interpret this in different ways. Order, freedom, how do we balance that? If you hold a church service at a certain time, is there flexibility and so on? We're going to then look at the ways maths aids our thinking because we use these ordered approaches. And we're going to look at ways we can address the challenges like anxiety about maths, about what we know. And then we'll come back and look further about maths and God. So mathematics is a field of study. So you can study mathematics, which you'll do every year of primary and secondary school and on through tertiary education. And mathematics is also a method. That is, you'll crunch numbers and then you can go on to more advanced methods. And then on the forum post for today, we have a very interesting forum on maths and God and how studying maths can tell us about the divine world. Albert Einstein, he said that there was something about the wonder and beauty of maths that also connected with his understanding of God behind it all. And then there was a wonderful diagram you might want to come back to, which says we've got the concrete number of maths. We're counting apples, 2 apples plus 2 apples. And then our mind is using language. And then there is the abstract concept. If you take away all of the apples, you can still think about 2 bananas plus 2 bananas or oranges, and you can take all that away. The concept doesn't change unless you want to do creative maths, which I don't think you're allowed to do too much of. 2 plus 2 equals 6 or 7. That doesn't go down so well. We have another article by Goodell in which he says, if you draw a circle around anything, then you still haven't explained everything. So there must be more. It must be the personal. It must be God behind it. Daniel, how did you find these articles which speak to us about something more powerful about maths than we normally think? We think of maths as a calculator. We think of maths as teaching students how to add and subtract. And yet these articles say that there is much more to maths. It connects with religion.
Yeah.
How did you find these articles as you began to read these, Daniel?
Well, I found them at first, I've obviously mentioned before my background in English and history, and I found them at first to be a little bit daunting, obviously, because it's not my area. And so wading into this week's topic, I'm thinking to myself, okay, this is going to be interesting. This could be a challenge. But I think what struck me was the extent to which mathematics serves or can serve not just as a reflection of God in terms of looking at the order and structure of the universe and the way things relate and correlate to each other, but seeing the way that various mathematicians, and there's a mention of some scientists as well, have used mathematics to understand the world around us, particularly Christian mathematicians and Christian scientists. I think the beautiful thing that struck me about this week's topic was the extent to which maths can actually operate as almost like a form of worship. It's a form of understanding the God that brought about the world and the universe that we're living in a way.
Yeah, and I like the way you share very honestly about the challenge of maths. And one of the things that this week's readings remind us is that even mathematicians find maths challenging. It doesn't always work out so well. And whatever activity you do, whether it be tennis in sport or whatever, or riding a bicycle, there are challenges, and it's normal to feel the challenges in mathematics. Another one of the readings on Moodle and the video on Moodle, we have at one point Dominic Baustra, Professor of Philosophy at Fordham University, and he says there's three different types of mathematics, three different schools. There's the Platonist, Plato, and he says there was the reality of numbers, 2 + 2 = 4. And then there's the formalist who says, no, these are just rules of logic in the game. And then there's the constructionist who says, no, it's the language that we use to construct what is going on. And to me, there's the analogy: you build a house and you've got measurements and dimensions for the foundation and walls and roof. Are these real, or are we sort of making them up? And so that's the sort of discussion that takes place amongst philosophers. And what Dominic Baustra, Professor of Philosophy, says is that many, many mathematicians tend to say there is the reality of the non-material. 2 + 2 = 4 is a reality that's out there, and this connects with God. And if you have things chaotically, 2 + 3 = 5 or 7, and you don't believe in God, then things start to fall apart. So a lot of people see reality as pointing to God. And Whitehead, who was a famous philosopher of mathematics, said that mathematics is a tool that guides us to understand the patterns that are around us. And he said that we're actually using God's language when we are using this. Kepler said, the laws of nature are the mathematical thoughts of God. And so we can actually get very close to God thoughts when we measure a triangle and say that the angles add up to 180 degrees. We're using a language of God, Kepler would argue, and he works out the movement of planets, etc., using that. In Colossians, in the Bible, we read, he is before all things and all things. And as you say, Daniel, this leads to a sense of worship. And so many people have said that maths points to this fascinating sense of God in all things. Do you always get that sense, Daniel, when you do maths, or is maths sometimes incredibly frustrating? I'm trying to balance the budget, or I'm trying to purchase something from the shop and work out what's happening there. Do you sometimes use maths in literature, or the frequency of certain words, etc.? How do you balance these frustrations, Daniel, with maths, and yet this claim that it's a language like a language of God?
That's a really interesting question. I think I'll start, I guess, in terms of my, the way I kind of operate with maths is that it's not my area. It's not something I'm particularly, I'm not bad at maths, but I naturally have to use it. We were talking about before, waking up at a certain point in the morning. I use it if I'm writing a journal article that I know, all right, for this particular journal article, I've got to write 5,000 words. Well, I need this amount of words for my introduction, this amount for this section and that section, this amount for the conclusion as well. So I'm certainly using it, in even in the area that I operate in, which is not maths, but I can't operate without maths in my area. And so, truth be told, I don't think I have this kind of understanding or this appreciation of maths as a reflection of divine order, or a tool to understand the world and to reflect on God. But it's interesting, I think, in watching and reading some of the material for this week, in encountering some of the perspectives and propositions put forth by experts in this area. It strikes me the extent to which mathematics is almost defined by this beautiful sense of relationships and sometimes symmetry and balance as well. So it's not something I think that I think about and appreciate, but it is something that fundamentally informs the field. And I think as we see the numerous thinkers from this week, it's a common thread that we see woven throughout a lot of their work.
And we see that in music. And so if you play middle C and then you go up an octave, there are mathematical relationships between the sounds. We see it with athletes who are running, they're using mathematics in what they do, in soccer, in sport. So mathematics is being used all around us. And then behind it all, there is this religious thought, Christian thought, that the God behind it, Psalm 94, does not he who fashioned the ear, he who fashioned the eye, he who disciplines, does he not know all things? And that human plans, often when we deviate from the mathematics that's been set in place, we've got a speedo on our car and people have worked out this is a safe speed to travel at. We've got our car should be serviced at the number of kilometres, and that if you follow these mathematical guidelines, you will do well. So all around us are these laws, and behind all this, we say there is the one who must be the order behind all things. And God else says, if you keep drawing circles, eventually you must include the one behind all things, which is God. And in Colossians 1:16, the one who creates the world, Paul, or the writer of Colossians, is talking about the beauty that's there. And so at the beginning of today's class, we can pray, Heavenly Father, you've created all things, including the mathematical framework around us. Help us to appreciate this beauty. Help us to appreciate all that we live in and breathe and participate in, including mathematics. And then also help us to understand that you forgive, you can take away the bad things, that you bring good into our lives, and that Jesus has brought a mathematical conclusion to sin and he's brought back again hope and restoration. Maths is around us even in our beliefs and in God. So in this subject this week, we're looking at maths and its usefulness, and we're looking at the way we can apply it in our classes. Now, the 7 liberal arts back in ancient Greece and Egypt and Rome included mathematics, but also language and grammar, but also rhetoric, the way we speak and communicate one with another. They included the maths of geometry, so you could measure out right angles and size of a foundation when you construct. And Jesus worked in Galilee with the construction of stone houses, and you can still go and visit those. You can still visit the house where Peter might have held the first church services there, and so on. So geometry was being used even by Jesus as he was following his father's trade of a carpenter and builder. And in trades today, electrician today, plumber today, I hope they follow the mathematical guidelines. I hope electricity is 240 volts when it is supplied to us, and no one's put extra wires in that do different things. When you do art, I hope that the colours and the lines fit with a sense of beauty being communicated. If you're a vet or if you're a doctor and nurse working with me, and if you have a concern, mathematics helps. And as you said before, Daniel, when you draw up an essay, there's an article by Griffith University professor on the balance in an essay, in which 10% of it could be the introduction, 10% of it the conclusion, so 2,000 words. You could have 200 words introduction and conclusion. If you've got 200 words a paragraph, the remaining 1,600 words could give you 8 paragraphs. And then if you look at the marking criteria, you're looking for 8 key points that you're wanting to make. One of them might be definitions, and then you go on and look at the other points in the essay question. So you analyse the essay question. So maths is, if you're not doing it consciously, you're doing it subconsciously there as well. Now, in a week essay, you might say, in 2022, many students were enrolled in schools in Australia. The retention rate was not high. Was high, and student ratio was quite good. However, growth in school enrolments was not so good. Or you could write an essay. In Australia in 2022, there were 4 million students enrolled in 9,000 schools. The retention rate was 80%, and the average ratio was 13.1. 13 to 1, and the annual growth rate was only 0.3%. So adding statistics to any of your essays is going to strengthen them and make them more effective. So maths is very useful. It communicates detail, it communicates clarity, and we trust maths. At the same time, this raises the question, why do we trust maths? Christians and philosophers would say that there is a sense of reliability and order in the universe, and even going back to the Psalms in the Old Testament, or the Gospels going back to Plato, Pythagoras, and others, they say there's a reliability in the world around us. And in the 16th, 17th centuries, as science is being developed, they're saying this reliability, Pascal, Copernicus, Kepler, they're saying this reliability points to a God behind it all. Daniel, do you think that's the case? Is the world chaotic? Or does the sense of order, which we also find in maths, and the sense of order in the world, suggest that there's something about? I mean, did hydrogen atoms from a Big Bang just happen to all come together? Did life come together? Or do things like maths and the natural world point to some sense of order behind all these things? What are your thoughts, Daniel?
Yeah, we were talking about this before, Sam, and you hinted earlier that we were sharing that even within Christianity, different denominations will have different perspectives on the nature of order versus chaos in the world in which we find ourselves. So, for example, we were talking about reformists and the idea that, or the belief that the world is structured and set about in a particular way. You know, certainly in Pentecostal spheres, we certainly hear about the fallen nature of the world and the chaotic nature of the world, albeit we belong to and are loved by a God who created what was meant to be an ordered and perfect world. And so even within, I think, different denominations, we see different variations of these concepts of order and chaos. And, you know, in terms of, I think, the extent to which maths can reflect on that, you know, I think, you know, when I think about the Big Bang, for instance, and think about the intense heat at the supposed creation of the universe, hydrogen atoms being compressed, and then you have an explosion of light. To me, that sounds very similar to God saying, "Let there be light." And so I think I think what struck me this week is that even in understandings of mathematics and science that we may traditionally have thought were, for lack of a better term, I guess, secular, actually still point to our understanding of God as being, or our understanding of the universe as being something that was put together by the smartest being to ever exist, and a being who understood, because they created the laws of nature and the universe and how things work together. So I think that's my traditional reflection. And I think, truth be told, like I said, the readings this week, I think, reinforced the concept for me that there are, for, again, lack of a better term, scientific ideas or mathematical ideas that maybe traditionally, when we've kind of glanced over or heard about, we've labeled as secular, but can actually point towards a all-knowing, all-loving God who built the universe with a specific plan in mind.
And so, whichever religious tradition we're a part of, there's a recognition of a sense of order, and there's a recognition that this is not only in the theology that we speak about, but it's also, to some extent, in the world that is around us. And it's fascinating that the father of the Big Bang Theory was a Catholic priest who,
Mm.
working with Einstein and others, was aware that there is a sense of order out there, and he proposed this. And the word Big Bang was used to try and disparage Georges Lemaitre's theory,
Mm.
that things could begin from a point and come into existence and spread. And then scientists talk about the wonder of the ways in which these hydrogen and helium atoms just come together and make stars, and then stars come apart again, and then they come together, and you've got all the elements that you need. If the earth forms, you've got the minerals, you've got the oxygen, everything just comes together, and there's this sense of order around. And if you look at the plants and look at the animals, there is order all around us. And then the psalmists and other biblical passages talk about you can have confidence in God, because
Mm.
there is a confidence that you can see. And mathematics partly examines this confidence. And so you've got Georges Lemaitre using mathematics to describe what may go on in the universe, and he comes up with a theory of Big Bang as a Catholic astronomer priest. And then you've got others like Albert Einstein challenge the idea of Newton that everything's just constant, and he comes up with theories that have been shown to be true. It was MC squared in 1905, and so on. So all around us, there is this evidence that it's not a chaotic world described by secularists, but there is something much more going on. Robert Boyle, the famous scientist, said, nature is nothing else but God acting according to certain laws which he had fixed. And so understanding the laws of the world around us, which are often understood in mathematical terms, that is motion of a car, it's mathematics, it's size of an engine, it's mathematics. The chair of mathematics at Cambridge, Isaac Barrow, said, experimentalists in science don't suspect that nature is inconsistent. It follows laws, and the great author of the universe has given these laws that are there. So going back to Plato, and they call that Platonic ideas, or going through the Bible, and that says some trust in chariots or horses, but we trust in God who's brought this sense of order in the world. It gives a sense of confidence in your life, that, like some Reformed theologians say, it's good to understand the laws that govern the world. If there
Mm.
are laws that govern good marks in mathematics, they govern good marks in your essays. You got to put 2,000 words into a 2,000 word essay in order to get those grades. So understand the laws that are out there. Now, maths has a certain beauty to it. There are certain patterns that fit in, and we can understand that beauty and those patterns, and you can get a great deal from seeking to understand what is going on there. And there are lots of patterns that we see there. Particularly interesting, I find, is the Fibonacci sequence. And
Mm.
so if you look at patterns in the natural world, then one of the most interesting ones is the patterns that Leonardo Fibonacci noticed, that you add 1 and 1, 2, you add 1 and 2, 3, you add 2 and 3, 5. In the natural world all around us, we see the spirals in a shell has 1, 1, 2, 3, 5, and so on, and you add 5 and 3, you get 8. You look around and you can see it in the storm over the sea, you can see it in a shell, you can see it in a galaxy, you can see it in a flower, you can see it in a sunflower. These patterns aren't just random, but other middle-age thinkers at the time of Leonardo da Vinci and others recognized from 1200 AD through to 1500 AD, there is a beauty in the world around us that suggests there's an incredible sense of order. When they built temples in ancient Greece in recognition of the gods who gave us the beautiful world, they would think about the golden rectangles and shapes building on the Fibonacci sequence, and that's the shape that they would seek to reflect what the gods
It
had
was interesting. I mean,
then. Yeah. So, what are your thoughts on
yeah, it was,
numbers, Daniel?
yeah. Looking at this week, I was reminded of the things that I'm aware of in nature that replicate the Fibonacci sequence, such as particular flowers or shells, pine cones as well. I didn't even know about the its existence in cauliflowers and pineapples. And it struck me in particular, looking at the particular slides on the golden ratio and the Greek temples, the extent to which we can see something, something as ordered and structured as the Fibonacci sequence in things that we might not typically associate with order and structure. We were kind of joking earlier about the extent to which maybe different teachers in different subject areas may or may not be ordered or structured. And we talked about art, for example, and I think we all have an experience of being in an art classroom and just it being absolute chaos. But in thinking about, in particular, the golden rectangle, for example, and thinking about the notion of perspective in art, particularly during the Renaissance, the extent to which good art, in terms of representing the natural world or representing something realistically, has to incorporate really critical mathematical principles in terms of notions of depth perception, of perspective, of shadow, even light as well, in contemplating if the light source is coming from this angle, where is there going to be shadow, where is there going to be light. You might have one object here and you're painting this object and you're saying, okay, the light source is coming from here, so this side of the object has got to be light. And then you paint another object down here and you think, okay, this object here has to also have the light source, but now I realize that these two objects are probably going to have reflections of each other. So the idea, great works of art are ones that understand mathematical principles of object and spatial relation as well. And so it really reinforced, I think, the key points that we're discussing today, the extent to which mathematics, as one of the foundational liberal arts subjects, informs and is critical to the study of so many other subject areas.
And as you say, an understanding of this can help you do well in your essays. You can understand that there's a structure to an essay. Introduction and conclusion should be similar in length. There's a structure to a paragraph. It should have at least more than 3 or 4 or 5 sentences so you can fully develop the argument that's there in a paragraph. So whatever subject we're working with, we're going to benefit from mathematics. And also, if you're going to a shop to purchase something, if you're going to buy a car, you can think about what mathematics can tell you. And looking back through history, some of the great thinkers in history were people who understood the beauty of mathematics, understood the power of mathematics, and then this was also connected to their religious sense that there is a beauty and there is a power in numbers that doesn't enable us to go and do our own thing, but we are governed by laws in the universe, and there is a lawgiver God behind all things. Poitras, in his theological writing on redeeming mathematics, God-centered approach to mathematics, says, take an example, 2 + 2 = 4, 2 apples + 2 apples. In the more abstract sense, if you print that on sheets of paper, it's still true. You don't have to have the apples that are there. Albert Einstein said, you find it surprising, I think, of the comprehensibility of the world as a miracle, an eternal mystery. He says the fact that we can comprehend the way these numbers work is as though we've been given the language of God, the secret of the language of God that is used to design and make this world. And so great thinkers like Einstein had noted that 2 + 2 = 4. It's a miracle. We can work this out. We can process it, and we can do other things with this. As I said, if you print this out on 10 printers, the truth still remains. It's not in the printers there. Flatland was a book written by Edwin Abbott, in which he said that mathematics, what if we described a flat world and someone multidimensional comes along? How could God, who has more dimensions, come and step into our world and bring something much greater? I really like the cartoon by Hobbes, Calvin and Hobbes, which says, I don't think maths is a science. I think it's a religion. So it's like miracles. You take a number like 2, another number like 2, and you put it together. Or you take, I'm going to buy an iPad for $1,200 and I want to pay it off over 12 months. I pay $100 a month. So we can use maths all the time. Now, what Calvin and Hobbes are saying is that if these numbers always work, you need faith to believe in these numbers. And if you're accepting things on faith, then it's religion, and it's in public schools. And therefore, maths, maybe we should all be maths atheists, and then we wouldn't have to do maths at all. So what do you think? Do you need faith to believe in maths? Do you agree that subjects like maths require faith? And students, you might want to pause the video and ask the question, is there a certain level of faith in maths, just as there is faith in God? Do you have any thoughts on faith and maths, Daniel?
Well, I think it reflects a little bit of what we looked at earlier in the extent to which there are different schools of thought within mathematics itself. And so I look at that that comic from Calvin and Hobbes, and I certainly think that does not reflect a Platonist view of mathematics by any stretch of the imagination. But I think there are certainly elements of mathematics that require faith, because in order to test a theorem, you are testing the theorem because you initially have faith that that theorem is correct. And so in order to advance any field, there has to be an element of experimentation and discovery. And you can't have experimentation and discovery without an essence of faith, either in the proving or disproving of a hypothesis, or faith in one's own ability, in essence, to test the laws and test the limits. So it might be that even if we think about if we relate that to something like testing a historical hypothesis, yes, there might be faith placed in different elements. It's not necessarily a faith in God, but it might be a faith in one's own capacity to understand something. But there is, in essence, always going to be an element of faith.
And so we've got that theory of Platonism, which could be called idealism, which many people say then there must be God, because we've got that sense of order that's in the world. And then there is formalism. That is, we develop our own forms, you do our own thing. But of course, if that's the case, then the universe could do the same as well. Bits of earth could pop up here or there. Plants wouldn't work, animals wouldn't work. So there seems to be more than formalism. And then it could all be constructivism. That is, we don't really know what's going on, but we just construct mathematical concepts. And many mathematicians go back to Platonism or idealism, and then this also can lead them to be believers. And so we find that 60, 70, 80, 90% of people in the world, in Australia, say they believe in God in one sense, because they see evidence of this order that's all around. So beyond constructivism and formalism, which we do, we construct our understandings of the world, is a true, real world that we can more fully understand. So mathematics is very useful in understanding this real world that's going on around us. It helps us develop our thinking when we can work our way slowly through a numerical question. I said buying an iPad before for $1,200 over 12 months. That's $100 a month. And so that's useful as well. And so mathematics develops the ability to think and promotes wisdom. So as you use mathematics, you're buying a car, you look at the interest rates, you look at the fuel consumption, and so mathematics promotes wisdom. Mathematics quickens our mind as we pose mathematical questions, we work with them. You may even have a fitness watch that tells you to do certain things. It's working with maths all the time. And so Pascal said, we may be like the grass or a reed, but we have a capacity to think. And part of that capacity to think is in terms of mathematics that we have. Interestingly, developing a maths textbook is not something new in the last couple of hundred years. Developing a maths textbook, they were doing that way back 2,000 years ago, and they had maths textbooks then, and you can still read these maths textbooks like Euclid's Elements. And besides the Bible, this is one of the most popular selling books over the last 2,000 years, because you want to know what's the definition of a mathematical unit, how do you work with a mathematical unit, how do you measure. So for 2,000 years, this has been a compulsory part of schooling. You can be like Howard and Hobbes and say, we don't want maths. Well, you can't have life without maths. You can't have a primary school classroom without maths. It's part of what we do. So if you want to take a bit of time to read Euclid's, then you could do that. Maths is related to logical thinking. Maths is related to understanding the world around us, ontology. Maths is related to how we think. And if you want to look up a philosophy of maths, then you could certainly explore the whole philosophy behind maths. And some students may find that fascinating and interesting. Why do we believe what we believe about mathematics? And so you could look up that resource in the Stanford Encyclopedia on philosophy of maths as well. And that would give you further insights into the nature of mathematics and how maths works for philosophers. So I encourage your students, take some time, pause the video perhaps to think about what's the usefulness of maths in everyday life, because one of the ways you can make it more attractive for students is to make it more real. And I encourage you, set up a shop, have every two students divide into pairs. One's the shopkeeper, one's the person who's coming in to buy something, and work through the questions that you're putting forward. Have a game, have a contest, work through those questions in an appropriate way to the level that you are working at. So there's steps in mathematics. You formulate a problem, and it could be, we're going to carpet this classroom that we're in with new carpet on the floors. How do we work out the length and breadth of the carpet? We're going to make a cake for 6 to 8 people. How do we work out the ingredients? Let's say we're making it for 3 times or 4 times the number of people, 24 to people to 32 people. How do we increase the number of eggs and milk and so on? We're planning a trip. The next step is you break down into the components, you list those components, you look at the assumptions, look at the tasks there, you think through what are we doing in each stage of buying the car and in everything that we are doing. So I encourage you, do some practical exercises with your students and think about those. One example could be area. I mentioned before the area of a floor. So you've got 3 meters by 4 meters, a typical bedroom. And then if you're wanting to do a triangle, that would be half of this. And so half length times base. So give some examples, practical examples, and you could go outside and do this. With a circle, it's more difficult because we're used to length and breadth, and so there's various ways that we can make an understanding of the area of a circle or circumference of a circle more understandable. And I encourage you, rather than just tell the students this is the formula for area of a circle, give them a contest working in groups of 1, 2, 3, 4. How do you work out the area of a circle? Come up with your own models and theories, because there's not just one way to work out the area of a circle. You break it up into pieces and make it like a rectangle, and then you work out diameter is all the way across, radius is half the way across. And so if you've got radius times half the circumference, then you got the area of a circle. It gives us pi r squared. So these are things, if you've got the capacity to work through these, and realize not everyone is going to be able to work this out in the same way or as easily. Some could get stressed over this, but we've got to make maths interesting. You've got to get excited and confident in maths, and you've got to be able to work with it easily. Now, one of the real challenges, of course, is that maths can bring up anxiety. So if you've got a class and you've got some students who are anxious about maths, or if you're a teacher who's anxious about maths, you're a primary school teacher in year 1, 2, 3, and you're being asked to take a substitute class in year 5 maths and so on, how do you help students with maths anxiety? Daniel, teacher comes to you, student comes to you, I got anxiety. What's the solution?
You know, I was thinking about this earlier, and it's funny. I'm glad you mentioned as well. What do you do if you're also a teacher that has anxiety? Because I had a moment last week where I'm not sure if I have it exactly here. No, I don't have the poem with me, but I was trying to give an example of how to measure the amount of beats in a line of poetry. And so I won't go into all the details, but basically the way you do it is it's a mathematical exercise in which you're kind of it's almost musical, where you're measuring the syllables per line. And it's something that always stresses me out, even though I'm, an English literature person, and this is something I'm very used to. It's because as soon as my brain thinks, all right, there's maths involved, that anxiety increases as a result. And so in thinking about how we can reduce some of that anxiety, I think there are some really good resources that we'll see come up on screen in just a little bit. But I think one thing that stood out to me this week in thinking about maths as reflective of or maths as reflective of God and order and structure. And certainly we will talk about in a sec the anxiety of one of the things that makes maths or can make maths anxiety producing is the notion of there being only one right answer in maths. And for someone who's, from the field of literature and history, used to multiple interpretations and subjective analysis, that can be quite daunting to think, okay, there's only one right answer here. But in thinking about maths as reflective of the divine creator, I think there's something beautiful in the sense that we can hand that mathematics anxiety over to God, knowing that this is his creation. He is the author of mathematics. This is something that reveals the nature of the world that he has created. And so I think there's something spiritual about being able to hand that over to God, because it is reflective of him and the way he has ordered the universe. And I love that we have the psalm here in the lecture notes for this week. And I think that really reinforces for me the concept that God is in everything. And it is sometimes so foreign to think of the fact that God is in mathematics and that God is in this random piece of poetry. He is in everything. And so I think handing that over to him, there is no being that is better than maths than God.
And I like what you say about God being in that pattern and order that's in poetry, the pattern and order that's in music. And if we're told to examine and analyze that, we can get anxiety about that task. Um, and there are a number of reasons for this anxiety. Marilyn Curtin Phillips said three of the main reasons for anxiety. Firstly, there's often imposed authority. That is, someone stands as the expert, and we are the student. And if you get it right, then maybe a pat on the head. But the chances are, when someone imposes authority on you, there's a power imbalance. They know the answer already. You got a 50-50 chance of getting this wrong. Secondly, there's public exposure. When you say to a student, we're going to give a maths test, and then we're going to pin the results on the notice board, and everyone will see. It's a bit like when they pick a sports team, and if you're the first two picked for the team, great. But if you're the second last person picked or the last person picked, public exposure is very disencouraging. And then there's deadlines. And so one of the things we can do to help resolve this is we don't impose our authority. Rather, we encourage creative response. We encourage students to have agency. And we ask, how would you work out the area of a triangle or a circle? And we listen to the students, and we value every approach that they take, because there's no wrong answer or right answer. And then in terms of public exposure, anytime we do have public exposure, everyone's a winner. Everyone gets top grades here. You're all HD students in God's eyes. And then in terms of time deadlines, we give people ample time. There is no deadline on completing this. It's all Pacific time. And you complete it in your time, and enjoy it. That's the one. If we have one rule, it is enjoy the exercise, enjoy the class, that we are measuring out the ingredients for making a cake. We're making the cake, and then we're consuming and eating the cake after we've made it. So now on the next page, you're going to be asked to calculate the number of dots. I'll ask you to do this, Daniel. I'll do this. And then we very quickly, in 3 seconds, you've got to calculate the number of dots. And then after that, we're going to ask you, what method did you use? And you could count them one at a time. You could look at groups of them, whatever. And so you ready? So 3, 2, 1, we're going to have 3 seconds to work out. All right. So how many dots? Right. So can everyone think about how many dots they've seen? But then can I get you to write down what was the method that you used to calculate? Because this is the important thing. We want to recognize here that students have different ways of working things out. And if you've got 10 students or 20 students, there could be 10 or 20 different ways of working out the problem. So, Daniel, what was the method you used to calculate the number of dots?
Well, I'll be honest and say that the method I used was very much informed by what the first line was. So because I counted 3 dots, my brain went, all right, I'm going to count in threes. So I went 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1. That's 10. And so, truth be told, had it have been 4, 3, 3, I might have found that trickier in terms of the way it was laid out. But it was interesting in looking at this, Sam. I love the setup of this question because it reflects what you were talking about before about asking students how they would do things, giving them the insight or giving them the opportunity and giving them the agency to explore and experiment. And it occurred to me when we're talking about those three producers of anxiety, being authority, public exposure, and timing. How often I wonder how many of us who have mathematics anxiety had that experience in a maths classroom where you can think about majority of the time when you're asked a question in maths, it's it'd be Sam or Daniel, what was your answer to number 2? Then if you don't answer in about 5 or 6 seconds, they go to someone else, and then you think, oh gosh. So just that, in that 5 or 6 seconds alone, you've got all 3 anxiety producing elements. And so this exercise in encouraging that agency, encouraging exploration, is so different to that. And so again, with that sense of agency, like I said, had those dots been laid out differently, I very well may have used a different method.
And I really like how we're dialoguing now, and you could get students to write a journal entry, and they could write down about what did they like about the mathematics class, what worked about the task that they did. You get them to dialogue one with another, to talk. And so mathematics is more than numbers. Mathematics is problems, very real problems that are in the world. You could talk about COVID, and I'm still very interested. What are the chances of me catching COVID? What are the risks that are out there? What are the chances of me passing away, etc.? So health questions have mathematics about them. At whatever stage of life you're at, you are asking questions about, how many of this clothing item do I need? What size do I need? These questions are all around. But if we see it as discovery, if we see it as part of life, as we see it as part of keeping a journal, writing down what's happening, we've all had authority imposed on us, public exposure, and that could be the same with music or other things that we do, certain sports. I know people who hate golf because their first experience of golf was the authority. You must do this. You did not do it right. Public exposure before others. You've only got a short amount of time. And when you've played a few sports like that, you don't go back to those sports. You take up a solitary sport where no one can see you or impose what they are doing. Some have the same experience with music. We've just had a famous musician who passed away this last week. And do you know the name of the musician? And he was told by his mother, who tried to teach him piano, that he was getting it all wrong, and it was such a pain, and never go near the piano again because it was so much trouble. It was a Burt Bacharach, I think it was. And he wanted to prove his mother so wrong. He kept going back to the piano, and he became one of the great songwriters of all time. And so it's interesting. It can work the other way if you if you react to these things. So certainly different ways. Some people can see in the dots 3 plus 3 plus 3. Others can see patterns of 2. Others
How did you know about that, Sam?
Yeah.
I'm curious. Did you do a similar thing, or were you?
I did the same as you. I saw 3, and then I said 3 lots of, because I want to get there quickly. So 3 lots of 3 equals 9, and then I've got to add that extra one that's on. So I'm used to adding those sorts of things quickly, but I've asked other students, and other students will put the numbers together. I guess, like you, if I was ever to ask to be multiplying 198 times 4, can you tell me what 198 times 4 is, Daniel?
Yes. It is 796.
And students, can you see what he did there? So, Daniel, what's the trick for doing 198 times 4?
I instead of doing 198, I did 200 times 4.
Yep.
And then I knew that actually it might not be 796, it might be a little bit less. I think it might be 792, sorry. 792. So I did
Yep.
I did 4 times 200.
Yeah.
Knowing that I've got, for every lot of 200, I've got a 2 that I didn't account for.
Yeah.
So 4 times 2, because there's 4 lots of the 200s, 4 times 2 is 8. So it's basically 4 times 200 minus 8, essentially.
Yeah.
So you can tell again that it wasn't perfect, but I recognized my mistake at least.
Yeah, that was good. I think that's very good. And I encourage you go to the shopping centre and you buy certain items, and one item's $1.98 and one item's $2.98. You don't say one, you just say about $2, about $3, and you can work out roughly what you're collecting, can't you? And so rounding off is very useful. And you do that in your essay. You work out, roughly so many words, so many pages, and so on. So maths anxiety is a real thing. I encourage you that every one of us will have anxiety at some stage in some subjects, including mathematics and other subjects. And that'll be written into our subconscious, because our subconscious wants to warn us there is a bad thing going to happen here ahead. And so people are going to impose authority on you. And so the response is encourage students. You always get it right. We've always got a safe place in this classroom. There are many ways to get this problem done. Encourage students. I'm listening. You're an active agent. You are choosing. We're not going to have you admit your wrongs before every person. And then don't put the time pressure on always. Realise, yes, there can be a game where we compete, but it's not a problem if you're slower. It's like a race, and everyone's a winner in our classrooms. So to overcome maths anxiety, we've got to show as teachers that we like our mathematics, show that we recognise there's value in mathematics. We've got to make it a pleasant experience. So you make a game out of it, a contest. We're now going to have our quiz for today, and we're going to see who can get it completed the fastest. You can remind people that in life, mathematics is going to be useful. And whether you're doing biology or whether you're doing art, bring maths into the tasks that you are doing. It's maths and English, two essential subjects, and there's lots of ways that we can make it valuable and make it work. So yeah, I think that's worked really very, very well. So you can't avoid maths, but James K.A. Smith said education is not just about the head, it's not just information, it's about formation, it's about growing, it's about enjoying, it's about what we love, what we value. And so we have to love mathematics in our classrooms. And maths educators said, Golden, that maths educators who set out to modify strongly held beliefs such as anxiety need to address the reasons for this. And we need to provide rich, varied, powerful, emotional classes where maths is celebrated. We see it as a valuable part. And we've all got some anxiety about it. If I open up the car engine, I've got anxiety about what's under bonnets, etc. But you've got to show some familiarity with that and get over these difficulties. So things to consider when teaching maths: listen to the students. Think about what's maths meant to you growing up. You've had some good times where you valued maths. I remember when we made a cake using maths, etc. And you've had tough times where you thought it's too hard. And it was like trying to jump 6 foot. I can step up 1 foot. You got to give me 6 1-foot steps for me to get up. Think about what are the routines, what are the liturgies of your classroom, how are we celebrating it, how are we seeing it as a positive experience, giving students agency. So what have you learned from today's class on maths, Daniel? What stands out from looking at maths? Initially, we often think, hey, I've just got to spoon feed the students. Here's how to do addition and subtraction. But as we reflect more on the possibility there's a religious dimension to it, there is a question of agency and empowerment, there's a question of addressing anxiety, What are some things, and as I asked Daniel this question, I encourage you students to think about what are some things that stood out to today's class, and I encourage you bring those to the discussion that we will have when we come together as a class online as well. What stood out to you today, Daniel?
Well, I think what stood out was we talked about the extent to which mathematics underpins so many other areas of study, but in addition to that, underpins so many of the things that we do in life. We talked about, for example, waking up at a particular time, seeing the engine gauge in our car. I was even thinking earlier of the extent to which, for those of us who are particularly sport inclined, the extent to which we use it in sport. I play soccer on a weekend and I'm a goalkeeper, and I have to position myself using geometry according to where the ball is, because if I'm positioned wrongly, it's going to be harder for me to dive and make a save. And in other sports, thinking about the mathematics of, for sports where you can get different points for different things, there's a crucial element of mathematics as to whether you should go for one thing or another. Like, in basketball, should I really take the risk and go for the 3-pointer here if there's half a second left on the clock, and I really should take the easy two to, send the game to overtime or something like that. And so fundamentally, what I think is the key takeaway for me is we have a real understanding as a result of the readings and as a result of our lecture, the extent to which maths underpins so many things we do in life. And we recognize as well that the reason for this is that it's reflective of the divine creator. And I think as teachers, we need to realize that what has traditionally, well, not traditionally, but what has for many people been a source of anxiety, we need to work really hard to fight against that, because this is something that we all need to use, that we'll use in whatever field of education or study we end up in. We'll use in our daily life from when we wake up to when we fall asleep. And we don't want this to be a source of anxiety and stress and frustration, either academically or personally, for our students. And I think knowing that God is a God of love and care and compassion, when we talk about encouraging student agency and making them feel valued and giving them a voice and not wanting to put them down or embarrass them in the classroom, that is a operation of, or that is a representation of maths that is so in tune with the creator who created it. A maths classroom that is loving, that is caring, because maths is a reflection of a God who is loving and caring.
And I love this, Daniel, is that maths is a gift. You can be given various gifts in life. You might be given a great book to read. You might be given a great electronic device to play with. But we have been given the gift of mathematics. We've been given the gift of language, we'll see in future weeks, and poetry and music. But we've been given the gift of mathematics. And in some ways, we have connection with one of the languages of God. And God speaks other languages as well. But one of the languages that he communicates with us is the language of mathematics, which is a language of reliability, a language of order, a language of structure. So I've loved this class today, Daniel. It's really encouraged me when I'm working with young people in terms of teaching maths or working with them in terms of maths. It's a subject to be enjoyed. It's a subject to be understood, not rushed, not imposed, but it's very good. I'm looking forward to the class where we meet together and discuss these things, and looking forward to the following week as well. So thank you. And it's been a real joy to be a part of this class together. See you all in class. Thank you.